Okay, we're moving on to 3.5. And I think 3.5 should be easy for the majority of the people in the class, simply because we've actually basically already talked about this, or you've seen it one way or another in this class. But 3.5, and again, it's just more graphing, so you basically just make your XY table if you're at all in doubt, and just plug in some numbers and plug and chug. So you'll eventually start plotting enough points to where you'll see what your graph is looking like, and it just takes a little practice, so don't be afraid to get in there and get dirty on it. But again, 3.5, rational function, so that means you have some polynomial p of x divided by another polynomial q of x. So an example of this could be basically anything. So f of x equals, you could simply have x squared minus 1 over x. You could have 1 over x. You could have something to higher degrees like, let's see, x minus 1 over x squared minus 1. Whoops, that was supposed to be minus x plus 1, let's say. These are all examples of rational functions. So, like I said, you've all seen it. Maybe just the terminology rational function might throw you off, but you already know what these are, so I don't really expect anyone to be too surprised. The next thing that you may not remember is reciprocal. Reciprocal function. And the way I always remember this is, let's say you have f of x is equal to x, and you want to find the reciprocal of this. Well, the main thing that you want to do is you want to find some function that you can multiply the original function by, so x times something that will give you 1. Okay? This is the way I always remembered it. So this function, the question mark, it has to be something that we can multiply by x, and then the outcome will be 1. So the only thing that I can think of is 1 over x. So if you work that out, x times 1 over x, this ends up being x over x, which anything divided by itself is equal to 1. So again, the reciprocal is basically just taking whatever function you have and giving it a power of -1, to where this makes you rewrite it like this, because anything to a negative exponent is technically putting it in the denominator, so it's making it a rational function. And also with rational functions, finding your reciprocals, a lot of times you're gonna be dealing with vertical asymptotes, and what a vertical asymptote is I'll just draw a quick picture of, let's see, where I'll use the xy axis I'll use the y-axis as your vertical asymptote. So you've got some function that's doing something like this. So it's never actually crossing the origin. So it's never coming up here, and it's never coming right here or right here. You can see that. So it's coming along, and as you hit 0, you have this vertical asymptote right on the y-axis. So that means your function it simply cannot equal 0. So that would be something like this, like we've already seen, the 1 over the x. And why can it not equal 0? Well, if your domain, which is your x values, the x values that you can plug into your function, if we could go to the origin to where x was 0, then you would technically have 1 over 0. And we all know we can't divide by 0, right? So you can't do this, so therefore you cannot go across the y-axis anywhere along here, which basically makes it, whoops, sorry about that, I forgot to turn my phone off, but where were we? So vertical asymptote. So we cannot have anything on the y-axis which is resembling our vertical asymptote, because we can't have 0 in our domain, which would make 0 to be our x, which would make us divide by 0, which we all know we can't do. so I think I already said that. Okay, let's look at one more example. Okay, another quick example here. What if we did something like this, where just by looking at this, you should know where our vertical asymptote is going to be, just because of the last example. We know it's going to be on your y-axis, again, simply because we can't divide by 0. So our domain is going to be everything except 0. So we cannot, no matter what, even if you don't know what the graph looks like, you should know that there's going to be a vertical asymptote on your y-axis. But 4 divided by x is going to look a lot like the 1 over x graph. So it will look really close to this here. I'm just a bad drawer. Let's see here. So at x being 1, y is going to be 4. So this point here should be kind of bumped out to about there. So this graph should look more like that. Okay. Same thing down here. If you bump out to 1, it's going to be negative 4. So this graph should have done something more like this. So ignore that part and this part. But anyways, that's your graph, and here's your vertical asymptote. Now let's try and find another example. Okay, here's a little bit more complicated example, maybe. It's negative 1 over x minus 3. Now, the main thing to do to find your vertical asymptote is to think, well, what is my domain for this function? Well, in this case, you've only got one restriction on your domain, and that's going to be dividing by 0. So you should ask yourself, what number can I plug in for x to make my denominator 0? And that one number that you're going to plug in there is going to be where your vertical asymptote actually is. So in this case, if you were confused, you could say, well, let's just take our denominator, and you can do this for every one of them, set it equal to 0, and you solve for x. So you're going to add 3 to both sides. So you're going to have x equals 3. So at x equals 3, 1, 2, 3, this is where your vertical asymptote will be. And what you're going to do to figure out the rest of your graph, what you can do is just do your xy table. And you know at x equals 3, you're going to have some number, or you're not going to have a number because you can't divide by 0. So what I would recommend to do is, start from 3, go backwards and go forward, and plug those numbers in for x, and plot those points. So at a couple of those points, after you did it, you would notice your graph is going to look something like this. But basically all this is just trial and error. So you have to get in there and start playing with your XY table, plug in some points. So that's literally all it is. This table here is going to save you. Just figure out where your vertical asymptote is, and then choose the values of x on either side of that. And that's going to help you plot your graph like we had just done.